The anti-tail of 3I/Atlas is larger than the distance to the Moon. The interstellar object 3I/Atlas arrived at a distance of about 270 million kilometers from Earth. By December 19, 2025, it will get to a perigee distance of 268.9 million kilometers, only 0.4% closer than it is today. The data collected by numerous observatories on Earth and in space will inform us in the coming weeks on the nature of 3I/Atlas. The latest images from December 14th and 15th, 2025 show a prominent anti-tail that extends out to 500,000 kilometers away from the nucleus of 3I/Atlas towards the Sun. This length is larger than the average distance to the Moon, 384,400 kilometers. An anti-tail of this size had never been observed before for a comet. To reach a scale of 500,000 kilometers over the past 45 days after perihelion, the sunward speed of the material in the anti-tail must be at least 130 meters per second relative to the nucleus of 3I/Atlas. Whether this speed can be maintained by sublimated dust or gas from pockets of ice facing the solar wind and solar radiation pressure remains to be studied. The alternative is a jet from a technological thruster. How unusual are the properties of the anti-tail displayed by 3I/Atlas? We do not have a good census of the population of interstellar objects, including any traffic of technological objects through the inner solar system. Our state-of-the-art survey telescopes, such as Pan-STARRS, Atlas, or Rubin, can only detect reflection of sunlight from objects that are larger than 100 meters in diameter, roughly the size of a football field, within a distance comparable to the Earth-Sun separation. This diameter is an order of magnitude bigger than the largest spacecraft that humanity launched so far. In addition, existing astronomical surveys would miss near-Earth objects that travel much faster than tens of kilometers per second, the typical speed of asteroids or comets. In order to assess whether an interstellar object is an outlier that deserves a high rank on the Loeb classification scale, discussed here, here, and here, we need to know the probability distribution functions for its properties. Our assessment will be more reliable as the sample of interstellar objects gets larger. The challenge is familiar for those who seek a partner from a small pool of dating candidates, as it is difficult to decide how exceptional any of the early dating candidates are until we sample a large number of them. Our interstellar dating pool might go beyond what science fiction writers imagine. Enrico Fermi's question, "Where is everybody?" is often asked by lonely people. Our best advice to them is to engage in the search. Earlier today, I received the following uplifting message from a young person who indeed wishes to engage in the search for interstellar technological objects.